Cape Codders, we all already are pretty well aware of the changes that are happening. On the back table, you'll be able to see a whole bunch of news clippings and events that are happening. We've identified and invited 10 or more of Falmouth boards and committees already involved with everything from local emergency planning to coastal resiliency and water resource protection, energy and conservation. After the presentations, we welcome all to participate in the discussion. I welcome Karen Price, who will introduce our speaker, Ellen Douglas. Karen is the president of the Needham League of Women Voters. She's co-chair of the steering committee that I've been a member of for environmental advocacy and action. And she's very active also with local action for the state league. We also welcome Stephanie Madsen and Max Holmes, both Falmouth residents who've been involved in research, education, and action in working to understand and mitigate the changes that we are facing. And they will join Ellen after her presentation. Karen?
Thank you, Pam. So on behalf of the League of Women Voters of Massachusetts, I would also like to welcome you. It's a great crowd, great turnout. Thanks for coming on this beautiful day in November. The League of Women Voters of Massachusetts is a statewide organization, as the name implies, with 47 local leagues operating in over 100 communities in Massachusetts. Today's forum is the fifth and last in our 2017 Climate and Energy Solutions Series, organized by the statewide committee that Pam referred to. Previous forums were held in Worcester, Boston, Winchester, and Lexington. The League of Women Voters of Falmouth organized this forum in collaboration with the steering committee, but believe me, they did all the work. The League is, just to talk a little bit about the League's work in the area of the environment. The League has been at the forefront of the environmental and energy issues for most of our 100-year history. Coming up on the anniversary, the 100-year, educating our members and the public and calling for action to preserve and protect the world we share. In Massachusetts, the League has supported groundbreaking legislation such as the Global Warming Solutions Act and the Green Communities Act, advocated for the creation and funding of the Massachusetts Water Resources Commission. A League representative sat on the State Superfund Advisory Committee to oversee the cleanup of hazardous waste spills and sites. And more than 40 years ago, the League was a co-founder of the Boston Harbor Association, whose original mission was to clean up Boston Harbor and restore the waterfront, proving that we can tackle big problems and succeed if we work together toward a common goal. Our keynote speaker today is Dr. Ellen Douglas. Dr. Douglas is a hydrologist and engineer with broad experience in the analysis of water-related issues. She earned a BS in hydrology and an MS in civil engineering and a PhD in water resources engineering in 2002. She joined the faculty of UMass Boston in 2006 and was granted tenure in 2012. Dr. Douglas's research interests include evaluating the impacts of climate change on New England hydrology, assessing the vulnerability of coastal communities to flooding, improving methods for sustainable water resource management, and monitoring the performance of river restoration through dam removal. And we also found out at lunch that she has 4 alpacas as pets. And dogs.
4 alpacas, 3 dogs, 2 rabbits, a cat, and a horse.
Okay. So she's also an animal lover. And has a little bit of land. She has authored or co-authored 29 peer-reviewed publications, 4 book chapters, and is a contributing author for the 2013 U.S. National Climate Assessment and the IPCC 5th Assessment Report. She is co-author of Climate Ready Boston, Results of the Boston Research Advisory Group, and Preparing for the Rising Tide, which you will hear more about soon. They outline the impacts of climate change on Boston and surrounding communities. So please welcome Dr. Ellen Dawes.
Can everybody hear me okay?
No.
I usually don't have any problem with projection.
Use the mic. Need the mic.
Hold the mic?
Yeah.
That better?
Need it.
Okay.
Yeah.
All right. So thanks for coming on this beautiful day. You could be outside doing something and instead you're in here learning about climate change. So I'll give you a whirlwind tour of some of the things we know about extreme events and their relationship with climate change, and then a little bit about some projects that I've been involved in to try to address the impacts. So we all have heard that, we often hear that records are being broken every time you listen to the weatherman or weatherwoman or National Weather Service. They're often saying these events are unprecedented, record-breaking, and records are always going to be broken, but generally, theoretically anyway, the time between events should get greater. But with climate change, actually just the opposite is happening. The time between records is getting shorter and shorter. For example, the 15 of the last 17 years have been the warmest on record. And in 2016, April 2016 became the warmest April on record, and it crushed the record by 0.5 degree, which is a lot actually when you're breaking records. July of 2016 wasn't just the warmest July, but it was the warmest month ever on record at that point. And then of course 2016 joined the others as a record warmest year, and it beat the record by almost 1 degree centigrade. Again, a very large margin for record breaking. And some people say, well, isn't this just part of natural climate variability? And oftentimes they'll say, well, aren't we just recovering from what's called the Little Ice Age, which was a dip in the global temperatures in the 1600s, 1700s, but it turns out that was just a regional effect. If you look at the temperatures across the hemisphere, they were fairly constant or just slowly, slightly decreasing until we get to the 1900s where they started sharply increasing. Also, we have ice core records that show that our CO2 concentrations from nearly of the last million years have varied about 100,000 year cycle, but never gotten over 300 parts per million. And now in the 2000s, we were almost at 400 parts per million, and now we're above that. And if we believe the projections, those concentrations of CO2 could increase in the future. So we know that climate change is happening and that humans are the predominant cause, and maybe you heard just yesterday the latest government report was released from the National Climate Assessment supporting this argument. In the IPCC that came out, the latest report by the IPCC that came out in 2013 stated that Earth's warming is unequivocal, and when the IPCC is a group of scientists and diplomats that have to agree on the wording. So when they say unequivocal, it's a stunning word. It's a stunning amount of certainty, and that it's extremely likely that human emissions are the cause of that. And the IPCC has come up with a very precise meaning for those words. So very likely means that the science says there's a greater than 95% certainty in that statement. Well, how do we know this? Well, one of the things I wanted to show you is a clip that Bloomberg put together that actually shows how we understand this attribution of climate change. So here's the record of temperatures from the late 1800s until now. And so the way we understand this is the scientific community has built these large climate models that represent the interactions between the land surface and the ocean and the atmosphere to understand how the Earth works. And so in order to understand why we have this increasing trend, they ran several different factors through. One of them was changes in the Earth's orbit. Well, that does have a small impact, but it doesn't represent the change in temperature. Well, how about solar? You hear a lot of people say, well, it's just solar cycles that cause it. Well, solar cycles do vary, but again, the magnitude of those changes are not nearly the magnitude the temperature causes. So what about volcanoes? Volcanoes happen every once in a while and actually have a cooling impact. So if you put those changes together, you can see that there are impacts, but they don't mimic that temperature signal that we've seen over the last more than 100 years. So what about human causes? So we have land use change, which has caused a slight cooling, actually, because of a change in albedo. What about ozone changes? That really has, again, small variability. All our natural systems vary over time, but the magnitude isn't as great. And, oops. And what about aerosols? So aerosols are like dust and particles that float in the air. If you've ever been to Asia, Southeast Asia, when they have a lot of biomass burning, it actually causes a cooling effect in some parts of the world. So that really doesn't mimic the temperature. Well, what about greenhouse gases, CO2, methane? Now you begin to see, when you run the greenhouse gases alone through the model, you begin to see this increasing temperature trend that begins to mimic what we've seen in the observations. So if we put all the human factors together, it turns out that now we finally have factors that actually mimic, that the models can mimic the observations of increasing temperature over time. So when you put all the factors, then the natural factors, the volcanoes, and the human impacts, you get actually an amazing match between what the model says the temperature increase should be and what we've actually observed. So this is a great illustration of how scientists actually know that humans are the cause. So what we're doing is we're taking fossil carbon, which is buried deep into the in the ground, oil and gas and coal, which has been separated from this large global carbon cycle, and we're actually adding it to the atmosphere, which is imbalancing the carbon cycle on a large scale. And these emissions don't seem to be improving. These colored lines actually show projections into the future of what carbon emissions could look like, and then the dotted line is actual measured emissions, and you can see we're still sort of following the higher emissions. So we're going to continue to see these impacts if we don't change our emissions in the future, or now and into the future. So the main point that I wanted to make in this talk is how that impacts, how these changes in global temperature actually impacts extreme events. And it turns out that, you know, even if you have a small change in average values of something, it can really have dramatic impacts on the extreme ends. So, for example, the IPCC, the Intergovernmental Panel on Climate Change, put out a special report in 2011 on extreme events, and they showed that a small change in the average can lead to big changes in frequency, intensity, the spatial extent, duration, and the timing of these extreme events, and we end up seeing these, what we hear a lot these days, these unprecedented events. So this is a graph of the presidentially declared disasters. So you know that when we have a big event like Hurricane Harvey or Irma, these areas apply for funding from the federal government to recover, and in order to do that they have to be declared a disaster area. And you can see that the blue is the US and the red is New England. We've seen an increase in these presidentially declared disasters over the last couple of decades. So the question is, what is the cause of that? Is this a climate change signal, or what's the, you know, what does this mean? And what does it mean about the future? So there's a subset of those disasters that NOAA keeps track of, called the billion-dollar disasters. So when these disasters cost more than $1 billion, then they get lumped into this billion-dollar disasters. And it turns out that tropical cyclones, which are known to us as hurricanes, are the major costing events. They cost the biggest amount, both on a total amount and on an individual or average amount. So tropical cyclones or hurricanes are really, for the US, the biggest impactors when it comes to these extreme events and the damages. So before we talk about climate change and how that's impacted, how that could be impacting extreme events, I wanted to talk a little bit more about what causes hurricanes, or how do hurricanes come about. Well, it turns out that a lot of things have to go right or wrong, depending on how you look at it, for a hurricane to form. You need to have sea surface temperatures at least this 80 degrees Fahrenheit, And it turns out that in September is when the highest sea surface temperatures are most expansive. And no coincidence, that's also the peak hurricane time. So you can see here, these are the high warm sea surface temperatures extend into the North Atlantic a bit, or the Mid-Atlantic. You also need to have a temperature profile that supports thunderstorms, because thunderstorms are the seeds for hurricanes. You need to have high humidity in the troposphere, and these little seeds, these thunderstorms, have to occur outside of 300 miles from the equator in order for the Coriolis effect to start them spinning, that whole spinning phenomenon. And you also have to have low wind shear, which is the difference between upper winds and lower winds, because if there's too much wind shear, it just rips apart these systems before they can actually organize into a hurricane. The other thing that makes a hurricane into a really big hurricane, at least one that hits the Gulf, is it turns out that there's this thing called the loop current. So in the Caribbean, the layer of warm temperature is very thick, and in the Gulf of Mexico, the layer of warm temperatures is actually relatively thin. But there's this current that comes up, and how much that extends into the Gulf, it changes year to year. Some years it really extends up into the Gulf and actually sheds these little eddies that can then, when a hurricane travels through the Gulf and over one of these warm eddies, it adds extra energy and causes the hurricane to intensify. It turns out that Hurricane Katrina and Rita occurred during one of these loop current eddies, and also so did Harvey. So that was the reason why it was able to intensify so quickly in such a short amount of time. So why are hurricane impacts becoming more costly? Well, if you ask any scientist a question, they'll usually say, well, it's complicated. It depends. There's a lot of factors. On the one hand, we're getting better at tracking hurricanes. We're getting better at knowing where they're going to hit. But on the other hand, according to Carrie Emanuel at MIT, we really haven't gotten any better at forecasting how intense they'll get, or how they actually intensify since the 90s. So we're getting better at tracking them, but there's a lot of complexity that we don't understand. On the other hand, there are many more of us living in very vulnerable areas, and we have more stuff. So global populations exposed to hurricanes has gone up 3 times since the 1970s. And if we account for inflation, so the increase in price and in population change, per capita wealth in the US has increased by about 50% since 1979. So in these areas where we're moving into, we have higher value property and stuff which are getting damaged. Now this is a graph that I took from a paper that was written in 2008, I think. It's down here, 2008. And it shows the population of coastal communities, coastal counties, and the dark was in 1930, so the darkest bars are 1930, and then sort of the grayer bars are 2005, so it shows population increase since the 1930s. And so this is the Northeast, New York, New Jersey, that's always been fairly densely populated. But here's Florida and Texas, and this particular, so the coastal county population has really increased in the south, and this is Harris County, which has increased 3 times since 1960 in its population, and Harris County is the one that got really pummeled during Hurricane Harvey. So this particular study took into account population change, took into account increased wealth, and then normalized the hurricane damage and found that there wasn't a trend, an actual trend in time in the hurricane damage. But that doesn't mean that it won't be true in the future. So these are just a bunch of graphs from different climate models that show the relationship between risk and storm surge, which is the main cause of impact along the coast. And in all these cases, different models give slightly different results, but they all show, the blue is actually current conditions, and the red is late 21st century conditions. They all show that for a given risk or return period, like the 100-year event, the storm surge will increase over time due to climate change. So right now, let me go back. Right now, most of the damage that we see, that increase in extreme event damages and billion-dollar events is because we're actually living in more vulnerable places. More of us are living in more vulnerable places, and we have more high-value property. But in the future, so climate change is sort of like adding salt to a big wound that we've sort of created ourselves. But in the future, that will it will add more. It will actually be more than adding salt to the wound. So what I wanted to give a little bit of inkling in is what does this all mean for us in coastal Massachusetts? As was mentioned in my introduction, I was a part of this Climate Ready Boston analysis that we did. So Boston, we brought together a bunch of scientists from the Boston area and from the Northeast to act like a little mini IPCC to look at the different impacts of climate change and what it could mean for the Boston and surrounding region. If you're interested in the details, you can go to climateready.boston.gov to see the report. We looked at 4 different impacts that are relevant to Boston and coastal Massachusetts: sea level rise, coastal storms, extreme precipitation, and extreme temperatures. I'm just going to talk about these very briefly today. So with respect to coastal storms, here in New England, we really don't get that many hurricanes. They happen occasionally, and by the time they get here, they're usually only a Category 1 at most. And because this process of intensification is complex and not perfectly understood, there's really no scientific consensus as to what the impacts of climate change are on hurricane intensification. But it is a really fascinating debate because there's like two thoughts in the scientific community about whether or not climate change is actually going to have an impact on whether climate change is going to have an impact on hurricanes. According to Kerry Emanuel, he has found that on the really intense hurricanes, that those we can count on them becoming even more powerful. So it doesn't really matter about the frequency, but it's the ones that are the powerful ones that are going to become more powerful in the future. And as far as the other major storms that impact coastal storms that impacts us, the extratropical storms, or what we affectionately call them here is nor'easters, they are actually a much bigger influence on us here, especially north of the Cape. We get 2 or 3 of those a year, and so they have a bigger impact just in frequency. But again, they're very complex, large-scale storms, and there hasn't been nearly as much research on nor'easters as there has been on hurricanes. And so there is a more active research on that now. And from what has been done, it appears that there hasn't been a big change or a big trend in nor'easters to date, but there does appear to have been some, and I haven't gotten a chance to read the National Climate Assessment, which just came out yesterday, which may have more to say about this, but there's some evidence that storms are tracking more north, and that the timing of these storms are changing. But even if we don't have a change, even if we get the same storms in the future that we've got in the past, sea level rise is actually going to allow those storms to have further damage further into inland. So I wanted to tell you a little bit about what, the factors that are involved in sea level rise. In the 20th century, thermal expansion was the main driver, so about 1 millimeter a year from thermal expansion. So as the water warms, it expands. You won't notice that in your glass or in your swimming pool, but given that the ocean covers 75% of the land surface, when the ocean begins to expand, we notice. So thermal expansion was a big driver. Also glacier, as the temperatures warm, glaciers melt. And amazingly, we've pulled so much water out of the ground for irrigation that it's actually caused a measurable increase in sea level rise. About 0.5 millimeter of sea level rise is due to extracting groundwater, putting it on a land surface, and ultimately it works its way into the ocean. I find that pretty amazing. And also, some ice melt on the Antarctic and Greenland ice sheets has together about 0.6 millimeters. So during the 20th century, it was this thermal expansion and to a lesser degree, the additional volume of water from glaciers and ice melt that has caused the observable sea level rise that we've seen so far. But in the 21st century, one of the big drivers, we're still going to have thermal expansion, and we're still going to have some glacier melt until the glaciers are gone. But the biggest impact in the 21st century is going to be how the ice sheets respond to this warming, not just the warming atmosphere, but also the warming of the ocean waters. So there's a lot of ice, potential ice that could melt in these ice sheets. So there's a lot of active research now trying to figure out how these ice sheets on Greenland and on Antarctica are going to be responding. So ice sheet dynamics actually is one of the biggest areas of uncertainty and also intense research to try to understand how these are going to add to sea level rise in the future. One of the most fascinating things that I learned about during this Climate Ready Boston analysis that we did was this thing called ice sheet fingerprints. So it turns out that not only is the melting of these ice sheets adding water to the ocean, but these ice sheets are so massive that they have their own gravitational pull and they pull the water surface up towards them. So this is actually a simple schematic done by a scientist back in the 1800s. So we've known about this ice sheet dynamic process for a long time. So this is just a little schematic of the ice sheet, and this line here shows, how the water surface would be if there wasn't this gravitational pull. But it turns out that they're so big that they actually draw the water up to them. And then as they melt, as these ice sheets lose mass, that gravitational field relaxes. And so the water close to an ice sheet drops, but farther away from the ice sheet, it actually rises. So in addition to adding water to the ocean, it's also causing for places far away from the ice sheets, like we are from Antarctica, a further increase in global sea level rise, which I find really scary and fascinating at the same time. So there was a study done. Greenland, because it's close, actually could cause a small decrease in relative to the global mean sea level rise. But the East Antarctica, and especially the West Antarctica, because we're so far away from them, as they melt, we're actually going to see, we could see a 20% or more increase above the global mean sea level rise because of this gravitational redistribution is what they call it. So depending on what our emissions scenario, so you remember I showed that plot that showed that our emissions are continuing to follow the high projections. Depending on what we do for carbon emissions in the future could mean that if we reduce our carbon emissions now, we could actually see only 2 or 3 feet of sea level rise by 2100. If we follow a moderate reduction in greenhouse gases, or a moderate trajectory, we could see 3 to 5 feet of sea level rise by 2100. But if we continue along that business as usual path, that intense energy use and pumping CO2 into the atmosphere, we could see 7 to 10 feet of sea level rise by 2100. So, that's not good news, but in a way, it shows us that what we do now can really have an impact on what we see in the future. So if we continue, Massachusetts is really leading the nation on reducing greenhouse gas emissions and adapting and mitigating. And so if we continue to be a leader and bring others along, we can really have an impact on which one of these trajectories, when it comes to sea level rise, we actually end up seeing by the end of the century. Of course, the king tide was a big event last year in Boston, and it turns out it's happening again tomorrow and Monday. So people went all over Boston and northern Massachusetts and took pictures. And so it's evidence that we're seeing flooding in areas that normally wouldn't flood. There's also already a call for people taking pictures for the king tide tomorrow as well. So all of this really, I know, isn't good news. It's always depressing to learn about these things. So I also wanted to share some good news. as well. So it turns out when it comes to disasters, these extreme events, we're actually getting much better. So right after Hurricane Harvey came out, the New York Times came out with an article that demonstrated that we really have gotten much better and much more coordinated at responding to these events, unless I guess you live in Puerto Rico. So as long as you live on the continental US, we've gotten much better. I'm not sure that anybody in Puerto Rico would agree with this. Also, even despite the fact that our administration has chosen to withdraw from the Paris Agreement, there's an alliance of states within the United States that have, there's 14 of them that have banded together to continue moving towards the Paris Agreement goals. That's good news. Boston and the Commonwealth, as I said, is leading the nation in climate change initiatives. You have the Global Warming Solutions Act, and this is actually making transitions. There are demonstrated transitions to renewables in Massachusetts, so we're really fortunate to live in a state that is progressive as Massachusetts. We have the Regional Greenhouse Gas Initiative, which was actually started in 2009 and continues despite the fact that there were threats that many states were going to pull out. So it's a demonstrated cap and trade approach where you reduce the total amount of CO2 for a region, but within the region, utilities can trade. If they're not able to afford to reduce their emissions, then they can buy credits from other utilities that are able to. So overall, it reduces the amount of emissions going into the atmosphere. And it also generates money that can be put towards energy efficiency and reduced electricity bills. So they went through a 5-year review and found that they're saving a lot of money and putting a lot of money towards these renewable energy and greenhouse gas abatement initiatives. So this PowerPoint will be available to all of you. I know there's a lot of information here, so you'll be able to look at this in detail at your leisure. Boston has a climate action plan, which many communities do, and it actually now, Boston itself is part of the 100 resilient communities around the planet, which is developed by the Rockefeller Foundation. At UMass Boston, I've been involved in a number of different initiatives. I wanted to just briefly talk about a couple of those. We've looked at social and institutional vulnerability, which I'm not going to talk a lot about. I would encourage you at some point to have Paul Kirshen come and give a talk, because he's done a lot of work at East Boston and with working with the community to help them come up with adaptation for climate change. And then I've also been involved in a number of vulnerability assessments for infrastructure. So I'm going to tell you a little bit about the Mass DOT work I did. So just briefly, we started working in East Boston in 2008 to try to understand how coastal flooding that we had mapped would impact this community. It's an environmental justice community, which means it's a community with a large population of minorities and low income, and so doesn't have the capacity to deal with climate change. And so we met with community members, got their thoughts on what they believe, what they knew about climate change. We educated them a little bit, got their feedback on different ways of adapting to climate change, and then that work has continued with bringing together the communities, the neighborhood organizations, as well as the governmental and institutional and infrastructure agencies like National Grid and Mass DOT and Boston Water and Sewer. They're all getting together and working out a climate change adaptation plan that meets the needs of all these different agencies, rather than each organization coming up with their own plan. And that's part of a Kresge Foundation grant called Climate Care. So I'm not going to tell you any more about that, but if you're interested, have Paul Kirshen come and give a talk to talk about that. It's fascinating, and it's been going on since 2008, so that's like 9 years working with this community, and now they're getting to the point where they're actually starting to implement some of this plan, which is really good news. The thing I wanted to tell you about just briefly this morning is the work that I've done with Mass DOT, looking at the vulnerability of the Central Artery project. And the reason why I wanted to tell you about that is because we finished this project, and Mass DOT actually funded us to do the entire coastline of Massachusetts. So the maps and the model output that you'll see in this will actually, by the end of next year, will be available to communities along the Cape and along all of the Massachusetts coastline. So Mass DOT looked at some of the maps we had put out previously and thought, wow, there's a lot of assets here that are vulnerable to flooding, so maybe we should think about what to do about this. So in particular, we've got the big dig that was submerged, the central artery was submerged below Boston, which is great, but you have these tunnel entrances that you can imagine. If salt water gets down in there, that's not a good thing. You also have these vent buildings that ventilate the tunnel, and they have these louvers, these openings for ventilation right at ground surface. So, and these vent buildings actually go like 3 or 4 or 5 stories below ground. And so that's where all the big electrical circuits and fans and all that stuff, all those things that don't like salt water. So, you know, there's a lot of infrastructure that is vulnerable if this place gets flooded. So they wanted us to take a look at this. So as I've already mentioned, we needed to look at both factors, both types of storms that cause flooding in Boston, the tropical storms and the extratropical storms. So we hired Woods Hole Group, which is here over in East Falmouth. They built this really big, great hydrodynamic model that could simulate hurricanes and nor'easters coming into the Boston area and the storm surge that resulted. This just shows the model grid, so it included the Atlantic so that the hurricanes and the nor'easters could come into, and they selected those that would impact Boston. We had a very fine grid, so any of you who are modelers know that, you know, the accuracy of your results has a lot to do with how close these little nodes are, where all the data are compiled, and so it's a very high resolution model. And as a result of this, we were able to come up with maps of flooding that didn't just show the extent, which is all we were able to show before, but actually showed the probabilities of flooding. So this is the probability of flooding in Boston under current conditions. So this is East Boston. You can see there's about a 1% or less chance of flooding in the East Boston area right now, a little bit in South Boston. But as we move into the future, so this is 2030, you can see not only the extent of flooding increases, but so does the risk of flooding. So now that green is about a 5% chance, so we've had a 5 times increase in the probability of flooding over about 4 decades, or 2 decades. And then this is by 2070. So the thing about 2070 is sea level rise will get high enough so that the Charles River Dam can be overtopped or short-circuited, as well as the Amelia Earhart Dam. So both of those dams were put in to prevent tidal inundation inland. And so once the sea level gets to a certain level, then a storm surge could actually overtop those dams and cause a lot of flooding behind them. And then you can, you know, so because it's high resolution, you can have these maps that can show really zoom in on the areas of interest. So these kinds of maps will be available to communities around along the coastline of Massachusetts once we're done with the coastal project that we're working on right now. And even the central artery resulted in a lot of data on for the North Coast, or the coastline above the Cape. A lot of communities have used this information for their own vulnerability analysis. So the data that was generated by this Mass DOT report has been very helpful to a wide variety of organizations and communities. And we anticipate the same thing will be true of the coastal project once that's done. Can see flood depths, the same thing, increase in depth and extent. So for Mass DOT, what this ultimately meant was both good news and bad news. There was some vulnerability of some of their infrastructure, but it's fairly low probability, and that gave them enough time to actually plan and incorporate these results into their strategies. There were some regional adaptation projects that they could take on, which they are. The bad news was that over time, more of these facilities, like the tunnel openings, like the vent buildings, like the infrastructure that supports the tunnel, are going to be flooded, and so they need to come up with, they're in the process of actually validating the results that we put in this report, and now incorporating those results into their strategy for the future. So, in conclusion to all this stuff that I've talked about this morning, I just wanted to leave with you a few ideas. First is that we know that greenhouse gases are the major cause of the warming that we observed since the late 1800s. And we also know that small changes in these mean values of the process can lead to larger changes at the extreme ends, for example, storms and precipitation temperatures. We know that reducing greenhouse gases now can really affect the impacts that we see later in the century. So it's important that we continue with the mitigation initiatives and accelerate the mitigation initiatives that we're doing right now. But we also know that since we have been pumping CO2 into the atmosphere at a pretty high rate for the last 100 years or so, that we have a certain amount of climate change that's embedded into the system, and so we're going to have to adapt. And certainly we know that if we ignore any of this, then whatever we try to do in the future, whatever designs or plans we make, are going to be wrong. So we need to take this into account. So what has been the role of climate change in these disasters? Well, as I already mentioned, extreme events will always happen, but they're happening more frequently and they're becoming more intense as the climate changes. What we've experienced already, as I said, is like putting salt into a deep wound that we've created ourselves by putting ourselves in more vulnerable places and having more valuable property. And so what we have to do in the future is sort of like the gorilla in the room, so we have to talk about what we're going to do about these things. If we're living in a floodplain, how are we going to deal with that as flooding gets more probable? So we know we have to think about floodplain development and coastal development. How are we going to deal with the fact that the seas are rising and will continue to rise? And as they do, coastal storms will impact farther inland. We know that we have social and economic inequities that make certain populations even more vulnerable to climate change. And so if we deal with those, if we deal with the inequalities, we can help reduce vulnerabilities as well. We know we have to think about sane and sustainable development in the future. And we have been, and we need to continue to think about how we're using our energy and how we can be more efficient. So these are all things that we have to continue to work on into the future. We've been making a lot of progress on things, and many of those things have been what they call low-hanging fruit. So energy efficiency is economically makes sense, and it also helps in mitigation. But there are these other issues that are harder that we have to continue to work on as well. So that's about all I had to say.
Thank you so much, Ellen. Ellen will join our two panelists, and next, Stephanie will talk about our local actions.
Do you want us to sit here?
Sure.
And just talk?
Yeah, Max can come up. And your questions and comments are invited as soon as we hear from Stephanie and Max. Stephanie works at Woods Hole Oceanographic. She's been leading the sustainability effort for the institution, and I've been happy to work with her.
Yeah, Pam and I work together. Is it easier, better if I stand up?
Yes, it is.
Great. Well, welcome for coming, Ellen. That was a tremendous. Okay. That
I don't think it's on.
Okay. How's this?
No.
No.
It'll take a minute to
Yeah, it takes a second.
Yep.
Is that better? Can you hear me?
No.
Just speak really loud.
Get everything's up. Okay, how about now?
Really close.
This?
Yeah.
Can you hear me? Okay. Hello, everybody. My name is Stephanie Madsen. I work at Woods Hole Oceanographic Institution. I'll probably refer to it as WHOI. Do you understand what I mean when I say WHOI? So it's Woods Hole Oceanographic. And I was working in a lab for the last 7 years in understanding paleoclimate, hurricane extremes in the past, and also sea level rise. So I can comment a lot of what Ellen was talking about. I recently shifted to a more solution-based position at Woods Hole. in the sustainability coordinator at Woods Hole. And it's been wonderful because I shifted from trying to research and understand extreme weather events and how it impacts us coastally and globally to now trying to implement solutions, to be part of a community of what can we do, like sort of the good news, what can we do to mitigate the effects of climate change. So I just to raise your hand, how many people were outside this morning enjoying this beautiful weather? A lot of people. It was absolutely gorgeous. And I live here in Falmouth, and I can say I think it's one of the most beautiful places possibly on the planet. I think it's absolutely beautiful. And how many people live here because of the natural beauty? It's a wonderful place to live. So when you love where you live, you want to protect where you live, correct? And so the takeaways for this, I think, are how do we protect where we live? And we're sort of zooming into Cape Cod. We heard about Boston area, and those maps are going to be completed, and so we're going to be able to see more detailed maps of Cape Cod. But how do we protect where we live? And if the protection thing seems so overwhelming because all the content and the information that we're getting makes you feel a little out of control, doesn't it? Like I was starting to get anxious. Looking at the slides and feeling, oh, what can I do? It feels a little bit out of control. But when you think about protection and then, sort of zoom into responsible management, then you start feeling a little more empowered, right? What can we do? How can we manage, given all the information that we have from all the reports and the maps? What can we do to make us feel a little more in control, and so that we can become part of this solution? And so the two things that I want you to take away from today, and I think Ellen was stressing this, was that we can collectively reduce our carbon emissions. We have the power to do that. And secondly, we can manage responsibly our coastline. We can. So what are the things that we can do? So I can give you some insight just from Woods Hole Oceanographic. We can increase our energy efficiency, and we are putting in a lot of LED lighting fixtures that can reduce our utility by 30%. Because honestly, I went into I Googled today, where does Massachusetts energy come from? Does anybody know?
Ken?
Well, 66% of it is natural gas. So they're fossil fuels. But 12% nuclear, then you get into coal. Solar's only 2% right now. It is expanding, but we're burning fossil fuels, putting them into the atmosphere, like CO2, creating this heat-trapping blanket that is warming not only the atmosphere but also the oceans and causing sea level rise, rampant rates of sea level rise. But what can we do? We need to decrease the amount of CO2 we're putting in the atmosphere. So as the sustainability coordinator for WHOI, we are doing everything we can. We're just starting, and we have so much more to do. Not only LED lights, but we just contract about 2 megawatts of off-site solar. We're putting solar panels on 2 of our roofs in March. And so we're doing whatever we can do. But I can tell you, we are emulating a lot of people in the Falmouth community already. So Woods Hole, Max works at Woods Hole Research Center, and they are almost net zero. So producing close, right? And
we'll be there.
You'll get there. And we rely on people from Cape Mid Island self-reliance. So we really rely collectively on a group of people, not only people at WHOI, but people in our community who are already making, and the League of Women Voters who are already showing us by example what you can do to help minimize the amount of carbon emissions. So we have so much more to do at Woods Hole Oceanographic, but we're working in that direction, and we have a real commitment to it. The other piece is, how do we manage the coastline responsibly? Well, we need information. In order to help solve problems, we need the tools. So as Ellen discussed, with the help of Woods Hole Group, who's based here in Falmouth, we need the tools. We need the maps. When we look at inundation potential, we need to know what areas, low-lying areas, are going to be inundated. So I brought lots of materials or tools for you so you feel more empowered. Not only are you becoming more educated, but you're actually, hopefully, will engage with some of these tools to help you make good decisions and help you manage the region responsibly. So a few things I just want to highlight because we are prone to hurricanes. There's a booklet in the back. These are created by Sea Grant, Homeowner's Guide to Prepare for Coastal Hazards. This is a wonderful piece of material for you to read. Questions and answers if you're purchasing real estate on Cape Cod. It would be great if all real estate agents had a copy of this. These, again, are available on the Sea Grant website, and I encourage you to take a copy home with you. There's also a paper in the back describing the difference between a hurricane and a nor'easter, because a lot of people don't understand the difference. And then I created this 2-page tool. Oops, there's 1 page. The back is double-sided, but how do we know sea level is rising? I actually had a discussion with someone at the landfall about this, and they said we were standing on the dock with the king tide, and I didn't know the king tide was tomorrow. I can't wait to take pictures. My office overlooks the dock at the landfall. And last year during the king tide, every day, the high tide, I'm like, oh my God, the dock is going to be inundated underwater. What are we going to do? And it was getting higher for those couple of days. And then somebody said to me, that sea levels are not rising. And I was like, oh, all right. What a great opportunity to educate. So I invited this person over to my office and pulled up Woods Hole tide gauge. It was a really interesting, easy way to show someone that sea level is rising. So I made a little tutorial for you to take home so that you could show people or look yourself, how do we know sea level is rising? The back page that is printed back there is a tool using new maps, and I think your maps are going to be a lot better because you show probability and percents of inundation, where this map generated by it's called climatecentral.org, Surging Seas. You're probably familiar with that tool, a fantastic tool. So I made a tutorial, how do you get on that? So when you go home, you can see, well, where do I live? Am I vulnerable? Are the streets getting to my home vulnerable? You can get on this tool and look and play with this little tool to raise the water level to see the resulting maps if your street will be inundated. So it's just sort of an empowering tool so that you're prepared. Not to be so afraid, it's for you to be prepared so you feel empowered and that you can adapt so that we can be resilient and still enjoy this beautiful place where we live. So thank you.
I'm Max Holmes. I'm the Deputy Director and Senior Scientist at the Woods Hole Research Center. First of all, can you hear me if I don't? Stephanie mentioned that she was getting anxious as she was listening to Ellen speak, and I was as well, and then I got more anxious when Stephanie was speaking, but for a different reason. Part of it was the message, and part of it was with these wonderful presentations, what's left for me? And then I kind of turned it around and I said, well, there's not that much left for me, so I have a pretty easy job and I can just say a few words and I'll be done and I'll participate hopefully in the discussion. So, what's left? Let me tell you a little bit about Woods Hole, and I know many of you are very familiar with this and some of you aren't, but there are multiple different scientific institutions in Woods Hole. Many people not in Woods Hole think of it all as one place, but in fact they're distinct places that interact in different ways. But this is my brief history of Woods Hole, and I'm going to start in 1888. It actually goes back a bit before that, but I'll start in 1888, and that's when the Marine Biological Laboratory was founded. They're still there. In 1930, Woods Hole Oceanographic Institution came along. They're the guys with the big boats that fly the oceans of the world. In 1975, at the Marine Biological Laboratory, the Ecosystem Center was founded by a guy named George Woodwell. And in 1985, he left and started the Woods Hole Research Center. So now I work at the Woods Hole Research Center. I've been there for 12 years. I worked for 10 years before that at the Marine Biological Laboratory, and I'm also a guest investigator at the Woods Hole Research Center. So they're all magnificent places. I should add that there's also USGS in Woods Hole. There's National Marine Fisheries, and they're actually the guys that were sort of there. The precursor of National Marine Fisheries was in Woods Hole prior to 1888 when the MBL was founded. they're all magnificent scientific institutions. All are trying hard to, I'd say, bridge the gap between the science and its application for hopefully wise public policy. I think the Woods Hole Research Center particularly shines in that area. We're a bunch of really good scientists, but we spend an awful lot of time thinking about how to get that science to people that are making decisions, whether it's voters or whether it's politicians, whether it's local, state, national, or international. And we kind of try to play in all of those arenas. I think that our efforts to try to bridge that gap is what's, for the last 4 years, got us named the world's #1 climate change think tank, and we're really proud about that. Let's see. Stephanie mentioned that we try to walk the walk. Our campus, we're almost at net carbon zero. We'll be there within the next few months so that we'll be producing at least as much energy in a year as we use in a year. And the way we're going to close that little bit of gap that we have right now is we're going to generate a little bit more. We have wind and solar, and we're going to use a little bit less. So we're really proud about that. We spent a lot of time at the sort of international level. Let me tell, actually, before I go there, I'll tell you a little bit about the kind of science we work on. We mainly work on land. We think about how the land surface, how forests and soils interact with the atmosphere, how we can keep the carbon that trees have and that soils have and that permafrost has, how we can keep that carbon locked up where it is, how we can restore forests where we can do that, how we can pull carbon out of the atmosphere by growing trees and so on. So we're focused mainly on the land, which Oceanographic mainly on the ocean, but we interact quite a bit as well. We work a lot. We've spent a lot of time sort of at the international level with the UN Framework Convention, FCCC, Framework Convention on Climate Change. Many of us were in Paris for the climate negotiations in 2015 when the nations of the world reached an agreement. We didn't know that agreement would be reached going into it, so it was fantastic that it was reached. At this point, I think we're at 196 countries are active participants. We, along with Syria, are not. Syria never signed. We've announced that we're pulling out. But as I think Ellen mentioned, as kind of embarrassing and horrible as that is for the leadership position of the United States, other countries are stepping up, states are stepping up, individuals, companies are stepping up, so progress continues. Ellen mentioned that yesterday the fourth National Climate Assessment was published. And this is just the executive summary. It's a big, thick thing, and it's a fantastic report, and it's a product of the U.S. government. It's led, the U.S. Global Climate Change Research Program puts it out. That sits in the executive branch of our government. This report was initiated 18 months ago. We had a different chief executive there, and we also had a different science advisor. That was John Holdren, who was the Woods Hole Research Center's director until Obama was elected, and Obama tore Holdren away from us. He spent 8 years as the president's science advisor and the director of the Office of Science and Technology Policy. But we have him back at the Woods Hole Research Center now. His position, you won't believe this, but his position has not yet been filled in the current administration. And yet, at any rate, the report came out, and kind of surprisingly, it was not watered down. It's a hard-hitting. The science is, I haven't read the whole thing. I've read the bullets, and it's strong and it's powerful, and the science is there. And it's left many people scratching their heads. And I'll conclude with, the Woods Hole Research Center director is Phil Duffy, and he was interviewed all over the place yesterday, and sort of the New York Times and Washington Post and on about this sort of disconnect between what this report says, this report from the U.S. government, and what some of the leadership in the U.S. government says. And
The Globe this morning.
The Globe this morning as well, yeah, it's kind of all over. And the New York Times quote of the day today, I'll conclude with that, is from Phil Duffy, and he's talking about this report. It says, it begs the question, where are members of the administration getting their information from? They're obviously not getting it from their own scientists. Oh, I forgot one thing. It's wonderful to get, this is a fantastic group, and we got to keep getting people together, different groups of people together. We're getting more and more active at the Woods Hole Research Center with bringing speakers in and having various events. We have two really cool ones coming up on November 30th. I think we're doing something with Falmouth Academy, actually, because in part because they have a bigger audience, a bigger auditorium, and also because they have a different audience. And we're jointly going to show an inconvenient sequel. So that's the sequel to The Inconvenient Truth. And a few days later, on December 4th, we're going to show a film called Mammoth. It's a short 26-minute film. It's about a crazy-ish idea of how reintroducing big animals to the Siberian Arctic can help keep the ground cold to the permafrost frozen and keep its carbon locked away. Features a story of a father and son group of Russian scientists. We've worked with those guys a lot. The son, Nikita Zimov, will be here to join in the panel conversation after the film. The way you will find out about these, and I should say that December 4th thing is not even quite positive yet. This is my lead up to get on our mailing list. And you'll hear about these events in detail and others. So I know many of you already are, but I'll start passing this around. And if you would like our monthly newsletter to hear about the events, please sign up.
Thank you all. I welcome everybody who came today. It's just been a great turnout. Do you have comments and questions?
Hi, I'm Bill Gordon. But I want to tell everybody what is Cape Light Compact. They pay for the energy audits, and a lot of people have even modern homes and they think they're all completely insulated. You'll find out that's not really the case. So if you're not using that energy, then you're decreasing the amount of carbon going in the air. The other thing is with your utility bill, I had a National Grid, I had a thing set up first to save me money because I don't like to spend money, but then I found out that with another group I would pay into, actually my National Grid bill price went up, but it was investment in renewables. So I figured, there's just two things I could say, and so check out Cape Light Compact because the energy audit's free, and then afterwards they have incentives and rebates and stuff on things. So good thing to do. Okay.
Richard Johnson, I live here in Falmouth, and I wonder if you could comment a little bit about the effect of sea level rise on groundwater levels. There's an isolated low point behind my house, and I noticed the trees around that are starting to collapse. I assume it's because of groundwater rise. This is a phenomenon that's going to have an impact far inland. If you could comment on what you might be able to say about that.
Well, I haven't done any research on that, but I do know that the groundwater is connected to to ocean water at the coast, and so as sea level rises, so does the water table. It takes a while for the water table to respond, but over time, as sea level increases, you're going to see increases in the water table as well. I always say that I think the Boston Groundwater Trust are the only people that are happy about sea level rise because it's actually causing an increase in groundwater in Boston, and they've been worried about the ties, the foundations under some of the old buildings being exposed, and so there is a direct link between the two. But that's all I know. Do you know more?
Well, I would just add that salt water is more dense than fresh water, and so if you get a lens that with sea level rise, you get an inundation in a lens underwater salt water, it'll elevate the fresh water above it.
There actually is a study that was done on the Cape of the impact by USGS.
Yeah.
on
That's right.
groundwater impact from sea level rise, 2, 4, and 6 feet, and they've mapped it out. So it's all out there.
I want to thank the panelists for their presentations, and my name is Keith Lewis and I live in Sandwich. I had a question for your thoughts about NRG's proposed expansion of the canal generating facility to add a third generator powered by natural gas. This has already been approved by local and state regulators, although the Conservation Law Foundation is now brought litigation to try and halt this. Does this appear to be sane and sustainable, to use your phrase, given the trajectory of our emissions already?
All right, I'll dive in. I would not be leading the charge to building new capacity to generate electricity from fossil fuel sources. If I had to pick my fossil fuel sources, I might lean toward methane, although there's or natural gas, although there are reasons to be concerned about that. But yeah, there are better ways to go to get the energy we need.
Hi, I wondered about the Center for Coastal Studies and where they come in relationship to the Woods Hole institutions. And they're guiding, of course, the Cape Cod Climate Change Collaborative, which I hope we're all part of.
Yeah, so they do fantastic work there in Provincetown. We don't have a tremendous amount of day-to-day interaction. They do some neat stuff. They do some water quality monitoring in the coastal zone. I'm interested in that. We do a lot of work on the rivers locally, and it connects to that kind of stuff. And I know that, yeah, they are leading the, as you mentioned, the Climate Change Collaborative. Yeah, which is kind of a new initiative, I think, and we'll, everyone's hopeful it's going to develop into a really neat thing.
So I'm Steve Gates. I actually am part of the 5 Cities, and we actually are going to be publishing for the people in this room a list of 350 things you can do to reduce your carbon footprint. A lot of them with data about how well that, which ones are most effective for both your pocketbook and or the climate. So, we have a sort of a preliminary version of that out on the site now. In another week or two, we'll probably have out that. But I had a question for the panelists, which is one of the scariest scientific papers I have ever read, and those are not usually words that you put together, right? Is a paper that looks at projections for climate change beyond the year 2100. And I'd like to hear what the panelists think about the science of projecting beyond 2100, as well as what your views of what your own personal projections are.
Well, you can run the model, so the models are, we're starting to look beyond 2100, even though 2100 seems like such a long ways away, and it's really hard to plan, and the uncertainties are much greater because we don't know, by 2100 even, we don't know what our CO2 trajectory is going to be. So even the projections at 2100 have a fair wide, if you saw remember any of the graphs that I showed, there's a fairly wide range of possibilities by 2100. But now, the projections are continuing on to 2200 and beyond. So the models are being used in the same way they're being used to project to 2100, just continuing on, and the uncertainties get greater because we know less about the future the farther you go out. So
this was also based on data from past ice ages and similar sorts of
yeah.
things. So it was really trying to take a really long picture.
I'm not familiar with, dealing with 2100 is hard enough, but I do know that, you're starting to see studies that are going out much farther, because hopefully we'll be around beyond 2100.
So with the paleoclimate work that we did at HUI, we looked at projections, and we looked at a lot of what projections are based on past data collected from the past. And what we're finding is it's very difficult to make projections with a small range of certainty until we collect more information from the past. And it turns out a lot of the data we're collecting from the past are land-based because we have access to that. We can collect the data. What I mean by data is tree ring data, looking at temperature or CO2 fluctuations from the deep paleoclimate and just the more recent paleo records. And we need more research to be done on these past climates to make better projections for the future. The other piece is we're finding policymakers, citizens aren't responding as strongly to projections because it's scary, number one, and two, it's how do you know? How can you say that? And then we're also seeing people go after the uncertainty. And one thing when I was a teacher, I would say, we are certain there is uncertainty. Why? Uncertainty, of course, is uncertainty. I can't tell you what the weather is going to be tomorrow for 100% sure, right? How many times is it, it says 30% chance of rain and it's raining outside? So people have to be more comfortable with the term uncertainty. We need uncertainty in science. Of course, we're never 100% sure about anything. But so what we were finding in our work was talking about the past versus making projections and showing pictures of hurricane inundation, storm surge from the 54 hurricane, from hurricanes that have occurred around here, Hurricane Bob, showing people pictures. We're finding they're moving towards making changes, mitigating the amount of CO2 in the atmosphere by looking at something tangible, pictures from the past. So those are my 2 cents about projections.
I think it's a great question, and the reality is that most of the models, the projections that you see, show change to 2100. So it I think it creates the illusion that, well, 2100 is as bad as it's going to get. But the reality is, if you go farther out to 22 to 2300, of course, the uncertainty gets bigger, but the impacts get an awful lot bigger. And I think that's important to recognize. I mean, hopefully it can, not that we need additional motivation, or not that we should need additional motivation, but if maybe that could do it.
Hi, I'm Kristen Morris from Falmouth. I have 2 things quickly. Town meeting is on Monday night, and there is a petitioner here who is putting a petition on called Article 8. I don't know where he is, but here he is back there. It actually calls for our town to recommend to the state that we divest from the public pension funds from fossil fuels. Our selectmen have unfortunately put it on indefinite postponement, but there may be a discussion on the floor. It seemed, and in the back is Grant Walker, who has some material on it. Then I have a question for Ellen. I wasn't here during the big dig, but I presume that this whole scientific approach of looking at what climate change could do wasn't in the picture then when they planned the big dig. And now, for example, with Amazon, say a big project like Amazon saying they might want to come to Boston, is Boston coming forth with some material like you have presented to talk about how Boston would then deal with climate change with a huge project like that?
Yeah, so we looked when we did the Central Artery project to see if they had taken climate change into consideration. And from what we could find for the big dig design, they really didn't consider sea level rise in their design. They did for Deer Island. So when Deer Island was built, the big wastewater treatment plant, that actually has an additional 2 feet because they wanted to account for climate change, but not for the big dig. But now, I've been doing this mapping and scaring people for at least the last decade, and that's what they keep telling me, accusing me of scaring people. Well, it's scary stuff, right? So we have, all those maps that I showed you, we have those available. We've been doing mapping of vulnerable areas for a long time, and what the city of Boston is doing right now, they don't have any constraints or recommendations or things that they're requiring developers to do, except they have to go through a checklist and they have to show they have to look at the available information and, say what level of sea level rise, what level of impacts are expected at your site, so that it's basically documented that they can't say they didn't know. And South Boston, where a lot of this development is happening, is also one of the areas, the Innovation District is also one of the areas that is very vulnerable to sea level rise and coastal storms in the future. And so I can't believe that a company like Amazon or GE or any of the big players coming in they can't not know about this. There's a lot of information out there, Climate Ready Boston, all that stuff. I saw a picture of GE's design of their facility, and it looks, the way they designed the structure, it looks like the first floor is would accommodate flooding. So their office space is going to be elevated. So people are aware, and I hope they're accounting for this.
I'm Pat Kerfoot. Underlying, is it on?
Put it down.
Underlying all of this is the increasing population of this earth. I happen to come from the era of Paul Ehrlich's zero population growth, and we can all see how effective that was. So my question is, has there been a study done of where this population increase will intersect with our efforts to decrease the effects of all of the CO2 in the atmosphere and other means of warming the earth, and where the crash is going to come? Is it possible to avoid the crash? Right now you say we're nibbling around the edges. Or are we, because there are other things coming into affect population, and we're decreasing our potable water supplies on this earth too. So I hate to sound so pessimistic, but this is what I'm hearing underlying all of this.
So yeah, I'm glad you brought up population. That's a huge driver of all this. There are 7.4 billion people on Earth right now. When I was born in 1965, there were 3.3. When my great-great-great-grandmother was born in 1820, there were 1 billion people. Where are we going to go? Are we going to go from 7.4 to 8, to 9, to 10, to 11? Nobody knows. I mean, you can look at the UN projections, and then you look at the uncertainty about that projection, and it's big. And it makes a big difference where we peak, and it makes a tremendous difference where this population of 7.4 or 8.5 or 10 or whatever gets its energy. So can we avoid a crash? Yeah, we can avoid a crash. We can get energy from different sources. We can stop spewing carbon dioxide and methane into the atmosphere. We have what we need to do it. On the technological side, right now, we don't on the political will side right now, and that's the limit, really.
I think the fact that they had the agreement of 196, did somebody say 196 countries have signed on to the Paris Climate Agreement? I think that was like the first great bulb of hope that we could work collectively together, that enough people are taking this seriously that we can start dealing with some of these really large scale problems.
My name is Sheila Silverberg. I live in Falmouth. On the issue of mitigating the problem, I understand that the ocean holds perhaps 40% of the carbon that comes out of the atmosphere. Is there any information on how we can prevent, because it sits probably mostly on the surface or a little bit below, what can we do to allow that carbon to sink even further and not put some of it back into the air?
Yeah, so human activities right now are putting about 10 billion tons of carbon into the atmosphere each year as carbon dioxide. Roughly half of it stays in the atmosphere, and that's why the carbon dioxide concentration is going up. The other half is roughly split between being absorbed by the ocean and being sucked up by plants on land, by photosynthesis on land. How can we keep that carbon in the ocean that's there? I mean, it's a fantastic question. There have been ideas about, wow, we can fertilize the ocean, cause more phytoplankton to grow. They sink out, get into the deep ocean, it stays there for a long time. It doesn't seem to work so well in practice, and there are all kinds of potential negative consequences of that. It doesn't seem to be a solution. Working against the ocean holding the carbon dioxide that is there is that as ocean waters warm, as they're warming, the equilibrium changes, and you can't keep as much carbon dioxide gas there. I don't think there's any magic bullet for keeping it there. What we need to do is stop putting so much up here. And we can pull it out by planting trees on land. That's what they do. That's where they're getting the carbon from the atmosphere. So we can restore forests and help reduce the carbon dioxide concentration in the atmosphere.
And I would add protecting the ocean to keep the amount of phytoplankton, because they take in a lot of CO2. So we want to protect that source of CO2 sink in addition to trees on land.
Vicki Lowell, it always seems better to talk about mitigation, and adaptation is sort of like you've surrendered to what's happening, but it's inevitable we're going to have more adaptation. And in one country in the world, Netherlands, has adapted to being a very low level, a below sea level country by building a lot of dikes. We have a fantastic amount of expensive infrastructure and development that are in very, very vulnerable areas. So for example, in Boston, has anyone talked about building a dike? Or it just seems like no matter what we do to adapt, it's going to be very expensive if we really do have 2, 3, 4 feet of sea level rise. And of course, the most poorer countries, the most vulnerable ones, won't have the money to even do it.
Well, yes, they have. As a matter of fact, right now, so someone proposed, I forget his name, but he proposed this idea of the Boston Harbor barrier back in the 1980s. And so the Barr Foundation, which is a philanthropic organization in Boston, has funded a study that's at UMass Boston to look at the feasibility. It's not designed, it's not even, saying it's going to happen, but answering the question, is it even feasible from an economic, from a social, and from an infrastructure standpoint? Is it feasible to consider putting a barrier across the Boston Harbor, mouth of the Boston Harbor, or maybe the inner harbor to try to protect some of that? So we should have that answer in about 6 more months. What's the feasibility?
So I'm going to stand up so that I'm a voice. But then I'll sit down after. I have one comment about international and a comment about local and climate change. Internationally, you've talked about the Paris Accord and the work that the Woods Hole Research Center is doing on land. The Paris Accord only mentions the ocean once, and it's in the preamble. So the United Nations has a long way to go to bring both the land and the oceans together. And so to affect the change, the adaptation, the mitigation that has to happen in the marine world, we've got a long way to go, and unfortunately, our current administration isn't supporting the United Nations. So that's the international scene. Locally, I attended a talk at the Woods Hole Research Center on Thursday or Wednesday when the artist Justin Rice Giglia gave a presentation, which was wonderful. It was about can science and art help change the world. So one of the things he mentioned that he had accomplished in his young life is that he had developed an app. If you have a smartphone, go look to get an app. It's free, called After Ice. And this visualizes data to help you understand right where you are now, how high sea level will be in 2080. So sitting here, I pulled up the app, and it's by way of a selfie. And it tells me that right here, the ground altitude is 27 feet. But in 2080, the water level in this room is going to be 32 feet. So I'm 5 feet underwater here. I did this at my office in Woods Hole at the Oceanographic. and my office is at 32 feet. And luckily, my feet will be getting wet. But by visualizing the data, it helps you understand that you need to do something. And right now, you have about 60 years. So anyway.
Maybe she's doing it right now. Just a couple more questions. It's anyone on the side again?
It's on in the back.
Would you comment about changes in rainfall? And this is a much more immediate issue, I think. Changes in rainfall and its implications for stormwater management.
Yeah. Well, stormwater management is an issue already because many of the stormwater drainage systems were designed, decades ago before population and urbanization had increased the way it has. And so we're already in a state where many of these systems are under-designed and so flood and back up on a regular basis. Any projections I've seen with respect to extreme precipitation show that it's going to increase in the future. And so rainfall in general is going to increase in the future, and at the extreme end, more so than in the average. And so we'll see more frequent and more intense rainfall events in the future. So that's going to mean more issues with stormwater management. So it's a problem. It's a problem that every municipality is struggling with. And a topic of my hydrology class right now, actually.
I wish we had time to answer all the questions and comments. It's just about 2:30 and we got to leave the building. Another group.
Okay.
No flood. But I just wanted to mention that we've mentioned the big conference. There's a big conference starting Monday in Bonn, Germany, hosted by the island of Fiji. And with thought ahead, they decided to have it in Germany where there would be fewer people traveling and fewer people merging on a little tiny island. I heard this morning on Living on Earth. The vision of Fiji is a grand coalition, and I think that all of us working locally and as communities, the states working together, which in the slide that Ellen showed, the states included Puerto Rico as one of the states wanting to attend and participate in the Paris Agreement. We can all work together, and there's a lot of information on the back table. So, thanks so much.
Guy from Santa was happy that I didn't. They got a girl who gave a